Okay, so we're ready. This is the beginning of chapter 8, and I have a nightmare about this particular problem because we did this problem in 8th grade where we took a shadow of the flagpole at our school in the playground, and we had to wait until a yardstick, which was 3 feet, was casting a 3-foot shadow. All right? And therefore, at that point, whatever the distance was from the base of the flagpole to the end of the shadow would be the height going up to the top of the flagpole. And so at lunch is when the sun was in the right place where the shadow was the same distance as the height of the thing. So I missed lunch that day, but I forgot to draw a mark where the shadow was. And so as I'm now measuring with a measuring stick, the shadow is moving. It's getting longer. And so when I got to the end, I didn't have the exact height of the flagpole. It bummed me out, but because I missed lunch and didn't have the right answer either. So at any rate, but this is what similar figures are about. All right, if you have a right triangle and these angles are the same, then this triangle and this triangle are dilations of one another. So I can either take this and divide it by a certain number and get this size, or I can take this and multiply it by a number to get that size. However, when you make two fractions with the parts of each of the triangles, the multiplier cancels out, and we have what we commonly call proportions. And so the base of 40 in relation to the height of the big triangle will equal 3 over 2 because there's some multiplier that both of these have to be multiplied by to make it the same size as this. But those things cancel out. And so what we have is a common proportion as long as the corresponding parts are in the same relationship in the 4 parts of that proportion. Right? And so based on this, how would you solve for h? You have to cross multiply, right? You get h by itself, and the 40 ends up here. And so what do you put in the calculator? 3 times 20. Okay, so what we're going to be talking about in this chapter are figures that are similar in nature, so therefore we can set up proportions to be able to find missing parts. Okay? Now, part 1 asks you, how do you know whether or not these shapes are proportional? Is there a multiplier that I can multiply this by that gets me this for every one of those sides? What is it? 2. It's 2. Therefore, these are similar figures because all of these multiplied by 2 would give me this. So if I dilated it 2 times as large, I would have the exact same shape. Okay, what about these two?
No.
Why?
Because, I mean, you could dilate it by 2 and a little bit, I guess. Like 2 and its decimal.
All right, so you got your calculators?
Kind of close, I guess.
Got your calculators? Okay, let's do this. What is 5 divided by 7?
0.7.
All right, now without clearing the calculator, what's 2 divided by 3?
1.6.
So the ratios are not equal. Now let's do that over here. Let's take these two, 8 divided by 6. Now let's take these two, 4 divided by 3. Same numbers, right? So therefore, because the ratios are exactly the same, these are similar figures. And so that we prove these are not because the ratios are not the same. Now, had I chose to say 5/2, which would be a ratio of the sides, is 7/3. This is 2.5, this is not 2.5. So again, because they're not equal, the ratios that we make that should be equal are not, and so these are not similar because they're not in proportion. Okay, so what happens on the next one? All right, look at the bases. What happened? What do I multiply this base to get that base?
1, 2.
2. All right, what happens if I do that here? What should that be? That should be a 6 if this is right, right? So therefore, are these two similar figures? The answer is no. They look, they're similar in that they're both isosceles triangles, but they're not proportional. So therefore, they're not, by definition, they're not similar. Okay, now what about here?
Yeah.
Why? All right. If I take the long on the short, this is 4 divided by 2, which is 2. This is 2 divided by 1, right? And so, however you do it, the sides are proportional, right? And the angles are the same, so therefore, those are similar figures. All right. Now, what about the next one? What about E? All right, now, how did we do the ones above it? How did we do these here? Right. There's no measurements to do this, right? So we can't tell. Because I needed a proportion of the size. I don't have a length here. Now, if this is 5 and this is 9, are they proportional? They might be, but I'd have to know about these sides as well, right? And so you can't tell because we don't know about the lengths. Okay? Circles? Are circles similar? Yes. All right, they all have a distance from the center, and so we could have the ratio of those things, so those are similar. All right, what about those? Squares? No. Wait a minute, squares are not similar?
Oh, yes, they are.
Yeah, they are. All right, what's the ratio? You have two choices. The ratio is 3:2 or 2:3. So if you're going to dial it down, you want 2/3 of this to get this size. If you start with here, you want 3/2, 1.5 to get that. All right, what about those? All right, now this is a trick. What kind of triangle is this? All right, wait a minute. No, look at it. It's equilateral. What about this?
Equilateral.
And in the equilateral triangle, all three angles are 60 degrees. So are those similar?
Yes.
Yes, although they're not drawn very well. Okay. All right, now when we get to these, all right, you've got some more work to do because this looks like it was doubled. What about this? So are they similar? No, because all the ratios do not equal the same values. All right, what about these two?
Yes.
All right, yes, because this is a multiplier of 3. This is a multiplier of 3. This ratio is 2:1, and this ratio is 2:1, so those are similar. All right, and then you'd have to work through these. You'd have to look at this angle. This is the right angle. Okay, and what I'm going to do is I'm going to come over here, and I'm going to say this is the right side and this is the left side of this right angle. This is the right side, this is the left side. So it means the right side is half the left side. Okay, now let's go over here. Over here, here is the right side, here is the left side. The right side is at half the left side. Yeah, so it looks like those things are proportional. And so they would be similar figures. The rest of the numbers, I've already looked at it, the rest of the numbers are all in the same order. All right, but we also had now, what about here? Okay, here's a 30 degree. The right side is 3 and the left side is 9. So the left side is 3 times what the right side is. All right, go up to this 30 degrees. The left side is 3 times what the right side is. So are those proportional? Yes, therefore they're similar figures. Okay, now what did I just demonstrate in looking at proportions and similar figures? Is that you've got to do some math. Okay, what's the math? Starts with a P. Yes. It has to be proportional. The sides have to be proportional. That means there has to be a fraction of corresponding parts that will simplify to the same value. Okay. All right, now. So, when you do number 2, you're going to do the same thing with these particular things. All right, now, equilateral triangle we just talked about. Are they similar? Yes, they could be larger or smaller, but they'll be similar. What about squares? Yes. Rectangles?
No.
You want to change your mind?
I don't.
Okay, well, all right, are the proportions of the sides, the width versus the length, do they all have to be the same proportion?
No.
No, they don't. So therefore, all rectangles are not going to be similar, but all squares will be. Okay? Now, an isosceles triangle. All right, we just saw an example of that. If the angles are different, they can still be isosceles, but they won't be similar. Okay, so not all isosceles triangles are similar. What about regular hexagons? Now this is important. Regular means all the sides are the same length. So isn't that like a square? Right, so a regular hexagon is similar in shape. All right, a regular n-gon. Yes. Same thing. If it doesn't have 6 sides, if it's got n sides on it, as long as it's regular, the angles are all the same, the sides are all the same length, so you're going to have the same proportion no matter which you compare. Now, congruent figures. This is interesting. What is the multiplier on congruent figures? What's the proportional multiplier for a congruent figure? Think of it this way. In a congruent figure, side A in this triangle is what with side A prime?
It's the same.
It's the same, so they are
All the same.
they are equal, right? They're equal. And so if you make a proportion of x over x, what does it simplify to? 1. And so in a congruent figure, the multiplier is 1. In a similar figure, the multiplier is something other than 1. It might be a half or 2/3 like we saw in those examples. So congruent figure is still similar, it just happens to be also identical. All right, but the multiplier is 1 with a congruent figure, and it'll be something other than 1, either greater or less, depending on which way you're headed in the dilation. Okay? All right, similar figure, all right, you can go through that one. Okay, here, okay? All right, if P and Q are points in the original picture and P prime are corresponding points on a poster, then if you look at the length from P prime to Q prime, and the relationship here, it's going to be, this is going to simplify to whatever the multiplier is. All right, and they gave the multiplier up here someplace. Yeah, here's the sides. Okay, so if you have, where's P and Q? Oh, that's not it. I thought that was that one. It is. That's weird. Oh, okay, I see what they're saying. Okay, so what's the difference between these figures? If the angle forms a line that's 97 degrees. All right, we're not going to have time to do that one. The tips of the cat's ears are C prime. This is C. That's not set up right. That can't be right. Oh, C prime is the nose. Okay, so what's the distance from here to here? Is what they're asking. Okay, and so you have I don't see B. All right, AB is here to here is 3. All right, this is 2 and this is 2. I didn't do that. If the distance between the ears is 1/2 the original picture, okay, so if you have this particular triangle, from A to B is this. So what is 1/2 of that? 1.5. All right, and I think that's the value you have to bring down into here. So when we have this, the ratio is still going to be 1/2. And so, therefore, when you put this together, you're going to have 1 over, excuse me, you're going to have 1 over 2 because the other one is smaller, and on this one you're going to have 2 over 1. Because the original is bigger. All right, ratios, proportions we've done. Okay. Okay, number 5. Are these sequences proportional? Look at A.
Yes.
Why?
Because it's going by a set.
So it's by 2, so it's 2x, okay? What about B? Okay, now, a lot of times it's easier to look at going from the small one to the large one.
Yes, it is.
All right, now you saw it, right? Huh?
3.
3?
No.
No. 2 times what is 14?
7.
And 5 times what is 35?
7.
7. So going from the smallest to the biggest is 7 times. 7 to 1. So going from the biggest to the smallest is 1 over 7. That's what this last one was showing us here. That one was 1/2 and the other was 2 over 1. Right, because it's the same proportion, it's just going from big to smaller, from smaller to big. All right, Kason, what are you working on there?
A circle.
Okay. All right, we're past that. Okay, now what about C? Are they in proportion? Okay, so what's the ratio from 2 to 5? You put that in your calculator. What's the ratio from 2 to 5? So 2 over 5.
1.1.
Okay, now don't erase it. So now do 0.5 over 1.25.
0.4.
All right, 3 over 7.5.
0.4.
So do they have the same ratio? So are they proportional?
Yeah.
How do you know? Because the ratios are all the same. Okay, and E makes the same distance, right? Okay. Okay, so look at C here in this one. Since the two sequences are proportional, we know that A over A prime and B over B prime, C over C prime, and D over D prime, etc. are all equal. Is it also true that the reciprocals will be equal? All right, let's think of that. Let's pretend that the ratio is 1/2. And the first one is 1 over 2, and the second one is 4 over 8, and the third one is 5 over 10, and D is 6 over 12. All of those will simplify to 1 over 2. All right, so the ratio between the prime and the original was 1/2. Okay, now let's flip the fraction and say that if you started with the small one and went to the large one, what would happen? Would you be going 2 times as big? So the ratio for A would be 2 over 1, and then it would be 4 over 2, it would be 3 over 6, and it would be 5 over 10. All right? So the numbers on the top, if they're the larger, and the numbers on the bottom are half of them, then the ratios of the reciprocals would still be equal to each other. Because it doesn't matter which one you pick. All that does is talk about the dilation, whether you're going smaller or larger. But if they're proportional and if they're similar figures, then all those proportions have to be the same, either the fraction or the reciprocal of fraction. Okay, so here's 2 sequences. Now, what does it say about them? The sequences, what? Are proportional. Okay, how do you show that? You start with 3 and go to 2. What's the ratio? Which is?
1.5.
All right, so show me what happens in the rest of those.
It's all ratio 1.5.
Yeah, and you'd have to check each one to prove that there was not there was not a mistake someplace. Okay, and I say that as a word of caution. Don't check 3 of them if there's 5, because if the last ones are not proportional, then it blows the whole thing. If the last ratio is not the same, then it blows it and it's not really proportional. So you have to check them all. Okay? Now, the second sequence is obtained by multiplying each number of the first sequence by what value? That's what you just told me. What do you multiply the first by in order to get the second? Okay, now here's something. When you do proportions, the starting number is on the bottom. So this says, in 8b, it says start with what? Start with the first and find the second. All right, so you're going to have 2 over 3. And 2 over 3 is 2/3, right? And so you're going to multiply the first sequence by 2/3, to end up with the second number of the sequence. That's what 8b is asking. Now, the second one was the one that we used. All right? What is the second sequence multiplied by to get the first sequence? That's the 1.5. Because you put the 3 on the top and the 2 on the bottom. Okay? All right, now, so then there's another similar figure. All right, that's all the same, so you can, when you work through that, you'll see that. Okay, now when we look at these, all right, if you notice, you see where the y is and the x. All right, now, do you remember me talking about the no choice theorem? All right, in problem A, the blank angle, we have no choice. It's going to be 180 minus x minus y. So all three of those angles are the same. Now, tell me about the left and right side of angle y. Up here in this one, the left side is 1.5 and the right side is 0.6. Let's make a fraction. Left side is over here. So let's go a fraction 0.6 divided by 1.5. Okay. Now let's do the same thing over here. We want the left side, which is 2 over 5. Same? They're both proportions. Now, if it's true, and then if I take the 1.2 and multiply it by that value, I should end up with 4. Did you? All right, so are they proportional? So they're all not proportional. So those things are not necessarily similar. Okay. Now look at B. All right, you have 60 degrees on the bottom, and the line in between them is 7 or 4. Okay, so what's the ratio in B of the smaller over the larger? All right, 10B, what's the ratio of the smaller over the larger? What, except that 4 is the length in between the two 60s, right? So it's 4 over which value?
7.
4 over 7, okay. So 4 over 7 is what ratio? That's the ratio that we're looking at. So now, if we do one of the other ones, which would be 2 over 3.5, same ratio. So in B, those figures are similar, because we have the same relationship and the same multiplier, right? Okay? Now, C. What happens in C?
Not proportional.
What? How do you know?
Because if you divide 2 divided by 4 and 1 divided by 3, then it's the same.
All right, and so you'd say 1 divided by 3 does not equal 2 divided by 4, and you're done. And you know, with no, okay? All right, and then you'd have to do the same type of things for D. So you go through that, and then E, F, and G are all so. And then this is the same problems we had earlier about squares. Can squares be proportional? Always. Equilateral triangles? Always. All right, 2 regular n-gons? Always. 2 congruent polygons? Always, because the multipliers are 1. But these over here, you have to see. Rectangles is no. Regular hexagons and congruent triangles. So the only one that's no is B. Okay. All right, now, this is the the corresponding angles are equal, therefore the triangles are similar. Now look at the symbol in between the two triangles over here. Look at the symbol. You notice it only has one line? All right. If it's equal, what does an equal sign look like?
Two lines.
Two lines that are exactly straight, right? That means they're congruent, basically. All right, if the two lines are similar, but they're curvy, that is the symbol for congruent. Now, distances are equal because there's only one dimension, distance. Right? So it's equal sign with straight lines. Congruent figures have the equal marks, have two, but they have a curvy. Because they're the same size and shape. But why do similar figures only have one curvy line? Because they're the same shape, but different sizes. So they're not equal in both ways, they're only equal in the same shape, but they're different sizes. Okay? So if on this one back here, where it said that you had two congruent figures, here, two congruent polygons, the symbol in between would be a double curvy line, because that's the symbol for congruent, right? The proportions, when we made the fractions, they would be equal because those proportions are just numbers, right? And when we talk about the figures that are similar, we have one curvy line. So it's sort of like equal, but it's not equal. Okay, does that make sense? All right, so now we're into here. All right, you see the equal marks? Because these are numbers that are calculated from the measurements of the sides. Okay, now here's my question. You see this triangle here? Where is vertex A located? Where is vertex A located in this triangle? Okay, you see this side A? Vertex A is over here, is a capital A. All right, here's side B. Where's angle B? Angle B is this one over here. Okay, here's side C. So where's angle C? Angle C is on the top. All right, that'll be needed when we get into trig functions too. So it's good to know that. Okay, and then this is more of the same when you're going to be trying to figure out. All right, if you look here, okay, if these are proportional, then you have 6 is to 5 as 7 is to x. Okay? So, 6 is to 5 as 7 is to x. All right, how do we solve that for x? All right, first thing I want to do is cross multiply and get the x up here. And then I need to cross multiply here, and so I'll have 7 times 5, but then I want to get rid of the 6. So when I do this cross multiply, I get 7 times 5. When I do this, I get 6x, but I just want the x there, so then I divide by 6. And so 35 divided by 6 is the proportion for those sides. So this has to be 35 divided by 6 is the length of that side. Almost 6, 5.9 something. Okay, so what do you see here? If these are proportional, all right, these two are in the same triangle. All right, the 10 is close to the angle, and this is the side opposite the angle. So I'm going to say this is 7 over 10. Side opposite the angle is x over 12, and they're equal. How do I solve it for x? you have to cross multiply. Okay? All right, so all of that works the same. So what, can you anticipate what the test is going to be for chapter 8? It's going to be a lot of algebra, isn't it? Setting up your proportions correctly. Okay, now let's look at this one here. This is L. All right, do you notice this is the right triangle? What's the length of this side down here in the bottom? The right leg of the right triangle here. All right, right triangles, a squared plus b squared equals c squared. So this is 25 minus 4. Square root of 21 is the length of this right leg. Okay, now when you look at the other triangle, the right leg is x. So x is equal to the square root of 21. And that's how you answer it. You don't put square root of 21 in the calculator because it's going to give you a decimal that you'll have to estimate. You just call it square root of 21. And now the other relationship for y, which is related to the 5, that one you'll do with proportions. And there's 3 or 4 that you could make with the 2, 5, the y, and the 3. But the other side is using Pythagorean theorem. Okay, so now let's look at this one. Here I've got an angle. Oh, that's weird, isn't it? All right. These two angles are the same. These angles on the other side are no choice because it's 180 minus 90 minus whatever the vertical angle is. But corresponding, this is which side of the triangle, of the right angle. This is the left side. And over here, this is the right side. So these two figures, they're not proportional because they're in different corresponding parts. So you've got to be careful. This x has to be compared with this side that's not marked. Now over here, all right, I have m. So this is the side opposite m, which is 4, and the side opposite the m here, which is 10. So I can set up that relationship. Right? This is the long leg of this triangle, and 8 is the long leg of that triangle, so I can set up proportions there, but on that other one, on n, I cannot, because I don't have the right information. Okay? All right, we've been through all of that. 11:20. What time did we stop? 11:40?
Yes.
Yeah. Okay. All right, this is another one that's important here. All right, number 23. Okay, this one says, consider the large right triangle cut into two similar, smaller right triangles with an altitude drawn to the hypotenuse. Decide which of the following statements are true. Okay. Now, you're supposed to decide this, but, ouch. I want to set this up here. In that small triangle, x would be part of the Pythagorean theorem, right? And it would be either the a or the b squared, right? And this is the c of c squared. However, in the big triangle, you have c, which, let me rename it. I'll name this A and this B. Okay, in the big triangle, a squared plus b squared equals, I'm going to call this d squared, the whole length. Right? That's the Pythagorean theorem. All right. In this small triangle, this is the hypotenuse. So that's x squared equals a squared. So this relationship here in the largest triangle, that length is the same as this one, right? And so what happens is this is the longer side of that triangle that I just drew, right? And so it's related to B. So X and B are related. And then in the small triangle, A is the hypotenuse, and, oops, sorry, it should go on the bottom. A goes on the bottom, and in the large hypotenuse, D is the hypotenuse, the large triangle. So those relationships go together. All right? But in this one, over here, the X is related to the shorter length. So A and X are related, and what you end up with when you cross multiply is you get x squared is equal to a times b. All right, that's what you're gonna be discovering when you look through here. And so you end up with a square root of the two numbers multiplied together. So see here you have long leg hypotenuse, long leg hypotenuse. All right, all of these are different. AB, AC, DC, and BC. Where's located? This is what you get to right here. But it's setting up that you have three similar triangles. You have three similar triangles. You have this triangle. It's similar to this triangle. It's similar to the whole triangle. All right, and then that one, what page is that on? 322, you need to look at that carefully because that's a test question and it's a very specific thing. Because when you find the part that relates, you're going to take the square root of the product of the other two, because this x is going to be here. It's down here and it's up here. So when this is the missing part and you cross multiply, you get x squared, and these numbers you're given, and so you're going to take the square root of these two numbers multiplied together. All right, so that's the one you've got to pick up off this drawing. Okay, so in each case, calculate the length indicated with the reference in the diagram. Okay, so BD, all right, BD is the short side, right? And BA is the hypotenuse. So find BC. BC is this side. Okay, so the hypotenuse of this one, which is x, okay, let's try this one. Okay, the hypotenuse of this is x. That's the hypotenuse. Okay? BA is the hypotenuse of this one. All right? That's in the big triangle, right? So I can say x over 9 is the short side over the hypotenuse. Now, BD is the short side. All right? So the short side BD goes here, and it's 4, and now the hypotenuse is x. If they're equal, x squared equals 36, x is 6. All right, so now this one says BC, BC is 8, and B to D is 4. And you need to find D to A. Okay, so D to A is X. Okay, now D to A would be defined as what? The long side of this triangle here. Okay, so the long side is X, and we're given the short side, which is 8. Then in this in this triangle, we can find this side with the Pythagorean theorem. Right? It's going to be the square root of 64 minus 16, 56, I think. Whatever it is. 64 minus 16, 46. Square root of 46. And so x and square root of 46. And then that becomes x squared is those right there, and then you simplify that. All right, so those are that's the second major skill in this section. So you've got to be able to work those problems. All right. Same thing again. See how they're using this particular triangle, similar triangles, and you've got to be able to identify the relationship. Now, one of the things that I said, and I want to go back over it, look at the right angle and compare whether or not the side is the short leg, the long leg, or the hypotenuse. So what are the three triangles here? There's this tiny triangle, and there's this other half of the triangle, and then there's the big triangle. Okay, so in the tiny triangle, where is the short leg in this tiny triangle? The short leg is x, right? Okay, in this triangle, the short leg is the dotted line. And in the big triangle, the short leg is A. Okay, and then you can move those around, but you've got to be able to see those three triangles and then understand that they are similar in proportion. All right, and that's what allows you to do those things that we just did. All right, and so that will help you there. Let's see. All right, when these lines are parallel, the small triangle and the big triangle are proportional when the line is parallel. If the line's not parallel, it's not true. But when these lines are parallel, because if the lines are parallel, the angles are the same because they're corresponding angles. So this angle down here at D and this angle up here that I'm looking at, those are corresponding with the two parallel lines cut by the transversal. Same thing here. This little angle here and the angle down here at B are corresponding angles because these two lines horizontally are both parallel. All right, now, what proportion would you set up for this triangle, assuming that the dotted line is parallel with the base? Because this is another trick. All right, what's the two sides of the small triangle? Real simple. What are the two sides that are given of 6 and x, right? 6 and x are the two sides of the small triangle. All right, what are the sides of the large triangle?
4 and 10.
No, 10 and x plus 2. See the trick?
Wait, where did the 10 come?
6, the whole triangle. See, not the part, the whole triangle. Okay? See how that works? Now see, if you don't recognize that to compare the sides of the big triangle, you have to start at the vertex and come all the way down, so it becomes 6 plus 4. All right? Once you get that, the rest of it is just proportions. But that becomes a trick problem on a test, because a lot of people are going to set the proportions up using the 4 and the 2 instead of the 10 and the x plus 2. Okay? All right, so what's that do to this problem? What's the big triangle sides? 7 and x plus 2. And over here, 4 plus x and 7 and x plus 9. Okay? These two are the same. So let's call this y. This will be y and 3, and then 2y and x plus 3. All right, what about these? 3/4 and 1 3/4, and then 5/6 and 5/6 plus x. Now, this is where you use the parts. All right, this is the base of the tiny triangle. So the base of the tiny triangle is 3, and the side is 5. The base of the large triangle is x, but the side is 7. And if you use the 2, it messes it all up. Okay? All right. All right, this is more of the same. And again, all right, so is this right here as the 3 triangles that are proportional? And it looks like all of them are measured by, all of them here are by k. So that means this should be, x should equal h divided by k. Because to go from this number to this number, you have to divide by k. Okay. All right. Okay, so ratio of a side to side, we've talked about that. If they're proportional, then it means that you can set up fractions. All right, corresponding angles are equal, right? If all the corresponding angles are equal, then the sides are, or then the triangles are similar to each other. And I'm surprised that they don't have the altitude. Here it is. The altitude drawn to the hypotenuse of a right triangle divides the triangle into 2 similar right triangles, which are similar to the overall original triangle. So when you draw the altitude down, you have 3 triangles, and we used to call them small, middle, large. The small one, the middle one, the large one. And the corresponding parts, the numbers jump to different places in each of the triangles. So the one that was the long leg in one triangle is a short leg in another triangle, and the one that was the hypotenuse in one triangle is a leg in another triangle. And so those are the things that you've got to be able to put together. Okay? All right, now, let's see if I've covered everything I need to cover. Okay, so your assignment on this chapter is to bring those things in, plus the Chapter 7 test and the midterm. The Chapter 7 test is the one from last week, the stuff that we did. And so you have the midterm test, and you'll have all the work for Chapter 8 that I want you to bring in. We started looking at these today, so you should be able to finish that up. I hope this was a better review than what we've done in the past. Okay. Also, I will send you the prerequisites, because that thing you've got to be able to pass in order to be able to take the 133. Okay, thank you. Have a good day.